Alright, kiddos, you guys should be close. You're writing down, because we're continuing section 2.6, you're writing down the next page from 2.6, you have your corrections all ready to turn in. Vicky's still going. Everybody else is here? I'm going to go ahead and hand back your quizzes. 2-1 to 2-4 at the end of class. You don't want me to keep it for this reason. We have a test coming this week. And what you didn't know for the quiz, maybe you've learned since then, but maybe you still don't know and you need to have it for the test. Does that make sense? And also, if your test percentage is able to be higher than your quiz percentage, I will replace the quiz percentage with the test percentage. Now, some of you are like, no. I like my 12 out of 10 on my quiz. Please don't touch that, and I won't. That's awesome. You did a great job. Or 11.5, or 9 out of 10 even. Or an 8, or a 7, depending on where you're used to doing in math. Those could all be great scores for you. But some of you that got 3s out of 10, or 4s out of 10, or 5s out of 10, you're like, I think I could do better on the test, so let's get that back today. Let's see where our weaknesses were, and let's study those for the test. Okay? We'll talk more about the test and the quiz a little bit later, but I wanted to go ahead and announce that because that way I make sure that I remember to pass it out before we're done. Kiddos, what's the section title for 2.6? Rational functions. And rational functions, aren't they fractions? You have an F over a G, and you have one written on the page. What did we talk about yesterday? Poles and vertical asymptotes, and both of them were types of discontinuities, aka. What's a discontinuity? Something that makes it discontinuous, that's true. Another way of putting it could be something that causes a gap. That could be. I was thinking. Oh, I just put 2 points in the wrong time. Right, okay. There are places where the domain does not exist. Discontinuity. Places where the domain does not exist or where the domain doesn't work. So, let's recap real fast from yesterday before we get into horizontal asymptotes. What do we have to watch out for with fractional functions or rational functions? The denominator in general. You have to watch out for the denominator, because what's the denominator not allowed to equal? 0. So when we looked at this function, we said right away, domain, x cannot be -2. But then I asked you the question, well, what's going on at -2? And we had to look at this page to realize what was going on. At -2, or this one, at -1, or at -2, what's happening in the graph could be just one little baby tiny point is missing. Or it could be you have a vertical asymptote where the whole graph is getting thrown off, in a sense. But how do we know the difference between just one little baby missing point or the whole graph getting thrown off? It all depends on what happens when you go to try to simplify. Because if you try to factor, the little baby point that's missing is going to be reduced away because the factors are going to match top and bottom. The vertical asymptotes are going to remain. So in homework, when it says to find a vertical asymptote, the first thing you should do is factor and reduce. That's the very first thing you should do. Get rid of any holes. And once all the holes are gone, the vertical asymptotes will be anything that's left that could not cancel out. Does that kind of make sense? Okay, so we're looking at the denominator. Where the denominator equals 0, there are problems. But if we can factor out where the denominator equals 0, it is not a vertical asymptote. It's a hole. So we factor, we simplify, then we ask ourselves, okay, what's left? Those are vertical asymptotes.
Can you review how you went from f of x with the parentheses to the vertical asymptote?
Yeah, I looked at the denominator, and I figured out my domain first of all by setting that 9 equal to 0, subtracting 2 from both sides. So I figured out -2 was a problem. How did I know it was a vertical asymptote? I asked myself, does 7 plus 2x match 2 plus x? And the answer was no. So since you can't simplify, this had to be a vertical asymptote. Does that make sense? Up here, at -1, that domain problem, since it was able to factor out, it was not a vertical asymptote. Instead, it was a hole. Now, do you guys remember when I sketched this really fast yesterday? I was like, hey, what does it look like? And I sketched the vertical asymptote. It's a dotted line. At x equals -2. Is that one line enough to get the whole graph? No. So what were some other things I used to help me get the graph? There is another line. What's this one called? But I didn't show you how to get it. I just said, hey, this one has a horizontal asymptote. We'll talk about it later. That's today. You just started taking notes on the horizontal asymptote. So we're going to figure out how to do the horizontal asymptote. Because if you guys look at this graph, that's really important to have both, right? Because then you know how to fit your curves in. Now, what was the only other clue really that I used? What are these points called? They're special points though, aren't they? Because that's the place where the graph is intersecting the x and y axis. Intercepts. The x and y intersect. So we're going to use intercepts today, or we're going to use horizontal and vertical asymptotes. We've already figured out vertical asymptotes, kind of. Horizontal asymptotes we're going to talk about next, and then we're going to say, hey, let's practice with intercepts if we can figure out the graphs of these functions. That's our goal today. We're going to figure out vertical asymptotes, horizontal asymptotes, and how to sketch some of these functions. Then we're done. Here we go. Sorry, there's one more thing I wanted to review. Behavior around vertical asymptotes. Once you have found a vertical asymptote, does it make sense to you guys why there was a vertical asymptote at -1? Look at the function up here.
Yes.
-1 makes the denominator 0. That's bad. And can I cancel out x plus 1? Oh, so it's not a whole. Okay, it's a vertical asymptote. So over, hi. So on the screen, oh my goodness. The silly news things. -1, there's a vertical asymptote. That's all we know so far. Now, I'm not talking about horizontal asymptotes or any of that stuff right now. All I'm asking is, how can you tell how to come into the vertical asymptote? Yesterday we saw you can come in going up at the x approaching positive infinity. Maybe it's that. But couldn't you also go down? And couldn't they also be opposite directions?
Maybe.
So, what do? You check the sign. What we saw yesterday is that you can use your table feature in your calculator, but it's going to take quite a while to approach, to come in towards -1 from the left, values below, like -1.5, -1.1, -1.0, and see what y is doing. Or to come from values above -0.5, -0.9, -0.99, see what's going on. And we were able to figure out that f of x was getting bigger and higher as the x's were coming from the left, and the y's were getting lower as the x's were coming from the right. But we also saw at the end of yesterday, mental mathers, or even those who were like, man, that table stuff takes a long time. You should like this, because how many points did I need to plug in? 5? 2. 1 from each side.
Yeah.
1 from each side. So you guys are both right. So 1 from each side. Okay? From the right, on the number line, does it make sense why I chose -0.99 or -0.9 or -0.99? I just had something, I needed something that was right to the right. That's really stinking close. I plugged it in. Wait, we never figured out what the number was. Guys, oh no, let's freak out. Let's go figure out the number. It's going to be awful. We don't have to. All we have to check is the sign. That's all we need. So then coming back. -3 was always negative. How did you guys figure out that this is going to be a positive without even figuring out that it's an actual positive 0.01? That's a math. Who wins? The 0.99 is negative, or the 1 is positive?
1, because 1 is bigger.
So then a negative over a positive is a negative. Alright. For some people, they didn't realize what we were doing because I went so fast at the end. So let's catch up real fast. A negative over a positive is a negative. So I know Vertical asymptotes will always be infinity. Tag the negative onto the infinity, and as I come from, wait, what direction? From the right. From the right. I need my function to be going down. I know it's going down because f of x needs to be approaching negative infinity from the right. Yeah, no.
Are you saying it's from the right because you got that -99 from the right?
Now, what does this say then if I plug in from the left, which is this value, and we did get a negative over, this one wins now, over a negative, which is a positive. What's my function need to be doing as I come into the vertical asymptote? It needs to be going. Now I know how to draw my graph almost entirely. Awesome. The only other questions we might ask are, where is the horizontal asymptote? Like, is it down here? Oh, that's what it is for. Calm down. Stop stressing. We're going to figure out the horizontal asymptote, and then we're going to figure out intercepts, and that's enough. That's close enough. Jackie, what was your question?
So why do the arrows like point towards the negative one?
Because the vertical asymptote is a line that a function keeps on approaching or getting infinitesimally close to without hitting, so it has to kind of come in and skim. Does that make sense? So it's coming in and skimming. It's not, we're not looking at end behavior. Actually, end behavior, that's what this page is all about. Awesome. Okay. So what's different about the vertical asymptotes is we're coming in, right? Now, with polynomials and end behaviors, weren't we going out? Right? This would be, what, a positive, even degree polynomial, right? What would this be? Negative? Odd. Negative odd. That's okay, we're reviewing, right? This would be a positive odd and a negative even. So we have positive even, positive odd, negative odd. But all of these, if I had like an x squared, the ends are going to be rising both ways, exactly. So positive even, a negative even flips, so it's falling both ways.
What about the like?
That's for x cubed, like an odd, or x to the fifth. If it's a positive, it's going to be falling and then rising.
Okay.
And if it's negative leading coefficient, it's rising and then falling. Does that make sense?
Mental note.
Okay. Now pause. Vertical asymptotes. Vertical asymptotes, we're not going out, we're coming in. So when I say, in this last one, when we were coming in and when the function was going, where was it going?
Oh.
As we come in, f of x from the, this is my
Left, right.
I know. I need to face you guys. Okay. Sorry, I do it the way that you guys see, so it is my right hand, but it's on your left side, right? Okay. So coming from the left, it was increasing. And coming from the right, it was decreasing. But you're coming in, and that was your question, Jack. You're coming into the vertical asymptote. Now, the question is, what's happening on these guys as you go out? To the right and to the left. I don't know. Exactly. It's okay. Here we go. What's going on? Horizontal asymptotes answers the question, what's going on as you go out? Vertical asymptote, what happens as you come in? Horizontal asymptote, what happens as you go out? So a horizontal asymptote is going to exist if, as you go out, you're getting closer and closer to one set height. Horizontal asymptote is going to occur when your y's are getting closer, approaching one number. I was just representative of a constant.
Oh,
I can put a number sign.
Okay, I can work with this.
Okay. So if y approaches a constant, a number, a horizontal asymptote is going to occur. As x goes to negative infinity, remember this is our way of saying to the negative infinity, to the left, right? The number line towards the negatives. And if x goes to positive infinity, this is going to the
right.
So this one, we're going, we're headed to the ends. We're not coming in, we're going out. Now, there are three different types of end behaviors that rational functions can have. And they are all symbolized, they are all shown in these three tests right here. I'm going to erase these, that was just for leaving space. There are three different things that can happen. There are three different types of rational functions that you can have. Either the top wins, explain in a second. Or the bottom wins. Kind of. Or they both tie. Or they tie. Now here's one thing you guys need to get down though. In order to win, it's all about the degree, not the coefficient. It's not about which one has a 10 and which one has a 100, which one has a 7 and which one has a 22. It's about which one has an x to a higher power. It's all about the degree. Just the degree. That's why it's called the degree test. It's all about the degree. It's all about the power, the highest power of x when you look at the top and the bottom. So either the top wins, his degree is greater, or the bottom wins, the denominator's degree is higher, or they have the exact same degree, probably different coefficients and signs and all that jazz, but the x power, the highest power of x will be the same. So here's what's going on. Long story short, if the top wins, you could do polynomial division, you would still get a polynomial at the end. So polynomials, always, whichever way you're going, are going to infinities, not a number. So therefore, if the top wins, there is no horizontal asymptote. And the reason is because the function will either be rising or falling as it goes to the right or to the left. It'll be like a polynomial. The top wins, if you did division, you would have a polynomial. That function is going to be rising or falling as you go to the right or to the left. But it will not have a horizontal asymptote. If the bottom wins, without going into tons of depth, if the bottom wins, I want you guys to think about the following example. Okay? Bottoms of fractions divide, right? Divide into pieces. Like if you had 1/4, the bottom says how many pieces you cut your pizza into, right? We're talking about pizzas. If you had 1/10, the bottom shows how many pieces we divided it into, right? So question, if the bottom wins, I want you to think of the following. As you go to infinity, if the degree of the bottom wins, you're dividing by bigger and bigger numbers. And those numbers are beating the numerators. The numerators are adding like whole pizzas, and the denominators are like cutting them into smaller and smaller pieces. Long story short, if the denominator wins, guys, what happens if you have one pizza, you're cutting it into tenths 1 second, then a hundredths the next second, then a thousandths the next second? How big are your slices getting? They're approaching 0. Not negative, because you're still going to have the pizza, but your slices are being, right? Okay. Long story short, your horizontal asymptote, whenever the bottom wins, just think it divides, it divides, it divides into smaller and smaller and smaller. You're approaching 0.
Will it ever hit 0?
No.
Whoa.
Not as you go to the right or to the left. No, in all actuality, well, here's actually a really good question, but to be honest, Joel, that's a question from like chapter 11.
Oh boy.
So we're not going to go too crazy.
Yeah,
Long story short is theoretically,
Sorry, guys.
theoretically, you'll never hit 0, but in all actuality, you can only divide so much
Right.
before you can't divide it the way that the math tells you to.
Mm-hmm.
So in all actuality, you got it.
I'm way ahead of y'all.
If you did all right.
I'm sorry.
Last but not least, if they tie, there is going to be a horizontal asymptote, but it is not going to be a 0.
X equals 0.
Oh, it is going to be y because it's horizontal. All these are y. It's okay. All these are y. They're all horizontal lines. Y equals. But in this one, it's going to be the ratio of the leading coefficients. Don't worry. We're basically going to make a little fraction out of the two terms that tie, the two highest. We're going to make a little fraction, cancel out the variables, and say, hey, what numbers are left? That is our horizontal asymptote. Ratio of leading coefficients means you take both of the terms of the top and bottom that tied, ignore the rest, because think about it this way. Philistines, right? David and Goliath. Why was Goliath the one fighting? She was theoretically the strongest from their army, right?
Yeah.
And they were hoping their strongest would intimidate, which it did for quite a while. They would intimidate the Israelites in order to basically give up the fight and be like, no, we're not willing to face you, so we're just going to back down, right? You send out your strongest. Same thing here. Take the strongest, take the two terms with the highest degree, ignore all the rest, and take a fraction of them. The variables will cancel out, and you'll have the leading coefficients left over. Let's go ahead and do some examples and see how they work.
Is that what you do with the last one? You showed you explain it to us later?
Yeah.
You did negative 7 over 2.
Exactly. That's exactly what I did. Let me show you, it's actually going to show up in this last one, Noah, as to what I did in the other. I want you guys to look at this fraction. Yes, there are numbers, and yes, they're important for most things, but for horizontal asymptotes, we only look at check out the degrees. Check out the degrees. So the top is a quadratic, the bottom is a linear. Who wins? Okay, so I want you guys to write, after you write down the example, top wins. If we were to do synthetic division, the quadratic would be taken down a notch from the linear, but it would still be a line. Lines increase forever, decrease forever, unless it's negative, but even then it rises and it falls. There's no horizontal asymptote. Guys, look at the test. From the notes that you just took, number 1, if the top wins, what do we say? No horizontal asymptote. As easy as that. As easy as that. What's different in number 2?
Oh wait, the bottom one.
Because the bottom's degree is 1, the top's degree is 0. Michael, what's going on with you a little bit? Don't worry. When you write down number 2, you're okay. When you write down number 2, I want you guys to write bottom wins. Right?
Yes.
The first one, top wins. The second one, bottom
It
wins.
has 1 more degree.
Oh.
The top one has a 0 degree. And the
I get it.
Yeah.
Look at test number 2 right up above. Yes, if you have a highlighter, this is a great thing to study, right? Horizontal asymptotes degree test, really important. Bottom wins. What does the test say?
Horizontal asymptote.
Y equals 0. Good. So you would draw a dotted line that the graph has to get closer and closer to the right and to the left at y equals 0. I know the one you're thinking of, the horizontal asymptote, was at a number. It was at 7 over 2. And actually the one before that, it was at positive 2. That only will happen not at the top wins, because there's none. Not at the bottom wins, it's always 0. But if there's a tie. No, it's a little different. Sorry, it's a little different. But similar to that one. So we have a tie. I think 7/2 was a different part of the answer. 2 was the one that we were looking at. 7/2 was an intercept, I think. Tie. Now guys, remember, think Goliath. Choose your strongest man. Who's the strongest out of 7 and 2x? 7. You would think 7, but it's all about degrees.
My bad.
It's all about degree.
That's my favorite.
So choose the 2x on top, choose the x on bottom, and your horizontal asymptote is, if you just choose those, you ignore the rest, the x's would cancel, and you would just have 2 over 1, which is 2. When I say ratio of the leading coefficients, I just mean choose the numbers in front of your strongest terms. That's your horizontal asymptote. Now, kiddos, hold on, pause. No, it's okay, it's okay. This third one was the exact same problem. I think you guys were right. It's the exact same problem as the one I graphed super fast yesterday.
Oh, you're right.
Do you see now why I put a dotted line horizontally at y equals 2? The light just turned on. Okay, so, pause. Time out. Pause and time out. No, listen. I said the culmination of this entire section was to figure out vertical asymptotes, to figure out horizontal asymptotes, and to try to sketch. This page says, hey, you have everything you need. This is the approach you should take to sketch. So if you think you need these steps, go ahead and write them down. It's just what do you think of if you need to sketch a rational function? What do you think of if you need to sketch a rational function? These are my way, or this is my way of telling you what to do when your homework says sketch in section 2.6. I'm just going to get through the steps very quickly, Chris, but hold on to that if you can. My very first step would be to factor and simplify, aka get rid of the holes. Factor and simplify, reduce, cancel out any common factors, aka get rid of any holes. And to be honest, kiddos, at this level, I'm not going to force you to even graph holes. Because the point of this section wasn't holes, it was vertical asymptotes and horizontal asymptotes. So factor and simplify. Factor and get rid of the holes. If you think you can figure out the holes, that's awesome. But that's not the focus. Factor and reduce. Number 2 says, find and plot y-intercepts. Hopefully this kind of rings a bell, y-intercepts, because we solved for them in chapter 1. We set x equal to 0. Some of you had to do corrections on this. Set x equal to 0, solve for y. Find any points where the function is going to hit the y-axis, which is going to happen when x is 0. Find any of the y's where it hits. So hopefully you guys can already know how to fill in number 3 almost. So what's going to change if we're crossing the x-axis now? Yeah, and solve for?
X.
Good. Solve for any of the x places where you're going to cross the x-axis. Now, if you have correctly factored and crossed out any holes in step 1, to find the vertical asymptotes, all you have to do is set the remaining denominators equal to 0. If you have gotten rid of your holes like you should, factor and simplify, whatever's left are vertical asymptotes. So take whatever is left in your denominator, set it equal to 0. Those are your vertical asymptotes. And did you guys notice I was graphing at those x values? I was graphing vertical dotted lines, right? At whatever the x's are, when you set the remaining denominator equal to 0, it's your domain restriction, D, the domain x cannot equal. Take all of those x's that you find and graph dotted vertical lines. You're going to graph dotted horizontal lines when you find the horizontal asymptotes, which is what we just did. And can you remember, when you look at a rational function, what are you thinking for top and bottom when you go to do horizontal asymptotes? Yeah. Who wins in the degrees? Not the coefficients, the degrees, right? You're going to do your degree tests. If there's no horizontal asymptote, then there's no horizontal dotted line anywhere. If there is a horizontal asymptote, you have to put it at the correct line. Is it 0? Or is it the ratio of the leading coefficient? Now, long story short on number 6 is, just like it was in chapter 1 with the polynomials. Actually, no. Earlier this chapter with the polynomials. If you need more points, if you're not exactly sure, some of you after all of that, you'll kind of know how to connect with the smooth curves. But some of you are like, I could use a few more points. And if you could use a few more points, maybe like in each of those gaps where you know the function needs to be coming in, if you could just have a couple more points, you would know how to connect and do your swoops. Make a table. You can always make a table, get a few more points, and then hopefully see how to connect. Number 6 is kind of optional. Some of you might not need it, but some of you, it's going to be a little tricky to graph, so making a table with a few extra points would be really helpful. Then you look at your graph and say, okay, can I figure out how to connect? Now, as you do that, technically, you should also be figuring out the vertical asymptote behavior, but sometimes by seeing everything else, sometimes you can kind of figure out what the vertical asymptote behavior should be as you come in. Sometimes the points are enough to show you how to graph. So, was this page meant to be like, hey, here's all kinds of brand new stuff? No, it's a culmination of this section. That's kind of the chapter. These are the clues. This is what I would say should be your step 1, step 2, step 3. Whenever the book says, what are the directions? Here we go. Sketch. So let's go ahead and do one. Let's go ahead and do one. And I have pretty much the steps really short and sweet, but written out here on the side. We're going to factor and simplify first. We're going to find our y-intercept, our x-intercept, see if there are any vertical asymptotes, see if there are any horizontal asymptotes. And then if we need to find some more points in the table, we will. You guys are getting down your function. Hopefully, first thing you're thinking is, how does this factor? Getting my sketch ready. Hopefully, your first question is, how does this factor? Has anybody gotten the difference of squares on top?
Minus 2x plus 2.
Good. X minus 2x plus 2 or x plus 2x minus 2. So if we're working together as a class, we're going to kind of lean on some people. Has anybody already factored the denominator for us?
H plus 3.
Careful.
It's x minus 2.
Yeah, we have to look at this last term. Factors of 2 that add to be 3. We want a 1 and 2. Let's see if that works.
Minus 2 minus.
Yeah. Negative 1 times negative 2 is a positive 2. Negative 1 plus negative 2 is a negative 3. Now, factor and simplify. Who are we supposed to get rid of right now?
H minus 2.
Yeah. Now, I said for right now, it's okay if you totally ignore the wholes. Technically, for those of you that are able to handle it, we would technically say x cannot be 2. We have to put a little hole whenever we get to x equals 2. But we can, for the rest of the problem, we can just look at this function right here. We can just look at the factored and simplified for the rest of the problem, okay? So now we have our, if you want to, y equals, if that helps, y equals x plus 2 over x minus 1. You guys should have in your steps right above what to do for the y and x intercept. Take a quick second so that you know what I'm about to do as I answer Jacob's question.
Why is it x can equal 2 instead of x can equal 1?
Because the x cannot equal 1 is still in there. I just had to write this because I took him away, so I wouldn't know that that's true if I just looked at this function without writing it.
So because we cancel it out, we know x can equal 2.
But technically, Jacob, that's a whole. So when we come to the graph, remember, you don't necessarily have to hold on to the whole for right now. But yeah, that is true. Y-intercept. Guys, if you look at your clues, do you understand why I'm setting x equal to 0?
Yes.
And I get negative 2, which means my y-intercept will be at the point when x is 0, y is negative 2. We'll graph that in a second. Did you look at your clues and realize for x-intercept, why I'm setting y equal to 0?
Yeah.
Now this one's a little bit trickier. I'm going to do my work over to the side because I don't really have a lot of down room. How do I get x alone? Algebra would say I have to multiply the denominator on the other side. But guys, what happens when I multiply 0 times anybody?
0.
0.
Yeah, so when you multiply x minus 1, the cool thing that's going to happen is you're always just going to get 0 equals the top. And some of you have already solved for x and figured out that x equals negative 2. When you multiply up the denominator, it's going to cancel out to be 0, and you just solve for x by subtracting 2 on both sides. So now, we know x is negative 2 when y is 0. Now, Jacob, I'm coming back to you because you saw the vertical asymptote. Because now is our time to say, hey, let's look at the function we now have. Is there still a problem? And the answer is yes. What did you see as to what else x cannot equal? Yeah. So here's where I write x cannot equal 1. That's my domain, which means there's a vertical asymptote at x equals 1. Not at 2 though, because 2 is a whole. They cancel out. 1 is the one that I'm going to need to make sure to get into my graph. So then so far. I have a point at 0, negative 2. I have a point at negative 2, 0. I have a vertical asymptote at 1. The last but not least is, who wins? I'm doing a degree test, horizontal asymptote. It is a tie. Not because of the numbers, but because x to the 1 and x to the 1. So guys, look at your degree test if you can. There's going to be a horizontal asymptote with a tie. I'm only going to take the winners. So x over x, and what does that reduce to be? 1. Or you can think reading coefficient, 1 over 1 will be 1. And they're both positive, so it's just a positive one. So now I can go over here and say, okay, 0, -2. I have a y-intercept at 0, -2. I have an x-intercept at -2, 0. I have a vertical asymptote at 1. I have a horizontal asymptote at 1. Can you guys already maybe figure out how these 2 points connect? Is it a straight line? But does it make sense that f of x is going to be approaching -infinity just from these 2 points? Cool. Maybe you don't need to do the whole check the behavior thing by plugging in 0.9999. Maybe you just connect and say, hey, it's going down. And then what has to happen as it comes up?
Approach.
He has to approach the horizontal asymptote. Pretend that was straight. Anyway. But the problem is, and why we might make a quick little baby table, have you guys noticed that on vertical asymptotes, there's always 2 sides? Struggle. The intercepts only helped us with one side. We have this whole other side that we don't know anything about. So if the vertical asymptote is at 1, do you think maybe we should plug in like 2 and 3 to a table just to get an idea?
Yes.
Okay. Let's just get an idea. We had some points over here. That was great. And it helped us be able to sketch it. But let's just make a little baby table. We'll do an x. We'll do a y. The nice thing is we don't have to use the original function. We can use the shortened, the simplified one, which is pretty cool. So if we plug in 2, 2 plus 2 is 4 over 2 minus 1. So no at 2. You guys double check my mental math. Is it 4? Okay. If I plug in 3, 3 plus 2 is 5, and 3 minus 1 is 2. So that'd be 2.5, right? So let's graph that. I have 1, I have 2, I have 3, I have 4. Okay. So at 2, I'm at 4. And at 3, I'm at 2.5. Can you guys tell how the function is going? It's going to be swooping in, good, towards the horizontal asymptote because it needs to be approaching. And can you tell that as I come in from the right, my behavior must be going to positive infinity? There's my function. I didn't even have to plug in 0.99 and 1.00001. The points gave me enough information once you get to know what a horizontal and vertical asymptote do. So once again, what was the point of today? Did we talk about vertical asymptotes and how to graph them with the dotted line and think about coming in? Yes. Did we talk about horizontal asymptotes and how to figure out whether or not there is one by checking the... Did we check the horizontal asymptotes? Top and bottom, the degrees. Who wins? Top or bottom, the degrees. And then did we talk about using intercepts and maybe a table to get a sketch? Yeah. Kiddos, that is basically the end of section 2.6, except there is one other special characteristic that can occur from time to time. And it only happens when the top wins by 1. It only happens when the top wins by 1. I'm talking about degrees. It only happens when the top wins by 1. You guys can write what you want from this page. I'm going to go ahead and show you how it works. I want to be able to talk about logistics and pass out quizzes. If the top wins by 1, we do a long division. If the top wins by 1, we do a long division. And I'm going to do it fairly quickly because today's point was not to learn long division. If the top wins by 1, we do a long division to find the slanty asymptote or the oblique asymptote. I'm going to distribute my negative. All I have is a 1. It doesn't go in. And let me show you where the slanting asymptote is. There's going to be an SA, that's actually surface area. We'll use OA for oblique asymptote at y equals It's not going to be a number because that would be horizontal. We're going to actually ignore the remainder. We're going to steal the other part and say, hey, that's your oblique asymptote. And what that means is when we go to graph this function with all the clues of the page before, the intercepts and the horizontal asymptotes and the vertical asymptotes, we need to, well, actually, there is no horizontal asymptote. The top wins by 1. We're not only going to graph the vertical asymptotes, but we're also going to graph a slanty asymptote. We're going to graph the line y equals x with dots. And the function is going to get closer and closer to that line. If you guys want to see what it looks like as I pass out the quizzes, you can graph the function on your calculator, and you can graph the line y equals x, and you will see that that function does not level off to a horizontal. It levels off to the y equals x line. You're going to see it again in homework as well. And kiddos, as I pass out your quizzes, you guys are taking, any juniors and below, you guys are taking your PSAT tomorrow, true? I told you guys that during period 5, since I have their entire class, we are going to grade on the videos. We're going to grade sections 2.5 and 2.6 tomorrow in class. Pass back to AJ. Pass back to Lynn. And so you guys are going to be responsible for, or to, grade with us watching the video tomorrow night, okay? Now, here's a quick dilemma. Someone brought up yesterday, right at the end of class, that there is a minimum day on Friday. Why is that a struggle? There's a test on Friday. Wait a minute. Isn't time always a hard thing? Pass back. Okay, so here's what we're going to do instead. We were supposed to squish in section 2.7. Pass back to Josh. We were supposed to squish in section 2.7 before the test on Friday, but instead we're going to actually cover 2.7 on Friday and have the test early. To be honest, we might actually be finishing the test a little bit on Friday. Now here's the dilemma. If you guys are taking the PSAT tomorrow, period 5 is going to have let's check homework and let's review. It's just going to be a work day in period 5. We're going to go over questions. I'm going to record it all so you guys can see it. We might do some good examples for the test. But the long story short is to give you guys as much time for the test as possible. Remember, you're going on retreat Monday and Tuesday. We can't have the test on Wednesday. You would all totally fail. Coming back. The minimum day is a horrible day for the test. So we're skipping 2.7 for the test. It's not going to be on the test at all, which is good. A whole section of material that's not going to be on there. It's going to make the test a little bit shorter because those 2 problems from 2.7 are going to actually leave off. And I might let you do them for like bonus the next week after we get back. The test will only be on sections 2.1 to 2.6. So you need to work on this homework tonight. Tomorrow you're going to need to watch the video to grade the homework and see how we review. The struggle is I'm not going to be able to see you tomorrow to say study, work on the chapter review, answer any questions or ask any questions that you have. That's on you. We will go ahead and be able to review this a little bit, answering last minute questions before the test since a whole section isn't on there. The test is shorter. But you need to work on the review tomorrow night in preparation for your test on Thursday. Kiddos, if you did not do any corrections yet, go ahead and go put them in the folder. These last few people, grab your quizzes and you do the room. Jaden, see how we do the video. Noah. I got worse, bro. I got worse. So I'll put in the folder, we can grab it out.